Okay, very important question. Remember, we had junk of some kind, not necessarily bad junk, divided by sine t, what, minus 1. We must make sure this is not 0. And an important question is, when is this 0? And hopefully everybody is starting to feel good about, I'll write these all up again one more time. Cosine 0 is 1. Cosine pi over 6, which is 30 degrees, is the square root of 3 over 2. Cosine of pi over 4, which is 45 degrees, is 1 over the square root of 2. Cosine of pi over 3, which is 60 degrees, is 1/2. And the cosine of pi over 2 is 0. That's the basic cosines, which are really important to know, which is why I keep going over them again and again. Now, let's think of this. We know that sine of 0 is 0. The sine of pi over 6, which is 30 degrees, is 1/2. The sine of pi over 4 is the same as the cosine, 1 over the square root of 2. The sine of pi over 3 is the square root of 3 over 2. This is happy junk. It's not, you know. Lastly, the sine of pi over 2 is 1. Why is this important? Because let's solve this equation. Let's add 1 to both sides, and this says that sine of t is equal to 1. So basically, this will be 0 when sine of t is equal to 1. Well, where exactly is sine of t equal to 1? It's pi over 2. We know that this is a periodic function with period 2 pi, so basically, it's not going to equal 1 anywhere else in the 2 pi range, or once around the circle, that is. So basically, when the angle is pi over 2, so here's our generic radius there. We're cranking this up to 90 degrees, which is now right here. So here, the radius and the y are the same level, so the sine of pi over 2 is going to be 1. Notice that the cosine of pi over 2 is x divided by r, and x is some positive measure. This is 0 because the x, here was the x at this low angle. As we start cranking this over, look what's happening to x. X is getting smaller and smaller and smaller. Well, y is getting bigger and bigger and bigger. So we know that this function is periodic with period 2 pi. So anytime we are at pi over 2 or pi over 2 plus 2 pi, I'm going to write this down, 2 plus 2 pi, or pi over 2 plus another 2 pi. Basically, a lot of your answers for these questions, they're going to say when is something something. And what you're going to have to do is you're going to have to say when t is equal to pi over 2 plus, let's see, 2k pi. Once again, this k is an element of the integers. This weird little e here means I'm an element of. And the integers are, of course, -3, -2, -1, 0, 1, 2, 3, . So what this is saying is that if you take any integer value, if k is 0, it's just originally what it is. If k is 1, it's gone down around here one time, 2 twice, -1 this way, -2 twice this way. These, I would like you to start being more and more comfortable with thinking in terms like this. So there's an infinite number of answers for this particular solution. It would be great if you would say t is not equal to 2 pi plus 2k pi. Oops, sorry, I mean pi over 2. Anytime you're dividing by something, you automatically have to make sure you're not dividing by 0. It's absolutely critical. I don't know where you're going to find yourself later. You don't even know. I did not start college thinking I was going to become a mathematics instructor. So try and keep these things in mind. I guess we'll move on to some other problems similar to this. You could become a math teacher. It could happen to you. Okay, another problem. You know what? Actually, I want to move on with this. These identities, these are pretty simple. What you've been asked to show, and right now nobody has really. Well, we'll do one more because this one looks kind of cool. So what do we got here? 4 cosine squared. T. Sine squared t. It's got a nice parentheses around it. Sine t over 4 cosine t. So they just want us to simplify this as best we can. Okay, so remember we're multiplying. I got a 4 on the bottom, a 4 on the top. 4 gets canceled. I have a sine on top, sine squared on the bottom. One of these goes away. This goes down to 1. I got a cosine squared on top and a cosine on the bottom. One of these goes away. This goes to 1. This ends up being cosine t over sine t. Incidentally, this is something I haven't defined yet, but I'll just point it out now. This is cotangent of t. Cotangent is just upside down tangent. This is basically equal to 1 over tangent t. I don't know what the book wants for an answer. This might be what the book wants for an answer. In like a week, we're going to be doing cotangent, secant, and cosecant. You don't got to sweat it right now. Let me see. I'm trying to look for some hard ones or some fun ones. Either way, however you want to think about it, and they really don't. Ooh, okay, so one more thing, and then I'm going to go on to something else. Suppose, and I'm just making this up, suppose I say that tangent t is equal to f of x divided by g of x. Find sine t. Or cosine t or whatever. So if I say that the tangent of something or any of these equals something, you need to know the definitions to draw the proper triangle. And this yellow is absolutely brilliant. I mean, it is like psychedelic. So here's t, and I said the tangent is this divided by this. Well, this must be y, and this must be x, right? So this here is f of x. This is g of x. Now all I have to do is figure out what this is. And we know that this is going to be this squared plus this squared square root. This is g of x squared plus f of x squared square root. So now what is sine t? Well, sine t, sine is just this divided by this. The sine of t then is f of x divided by gx squared plus fx squared square root. I just made that up. The reason, and you might be wondering, this is starting to get really abstract. They're not even numbers. You're saying that the tangent of some angle or some functions, when you get to calculus, this is where it's going to be going, Cal 2. And if I say something ridiculous, if I say that tangent t is hamster, it's ridiculous, right? How would you do it? What you would do is you know that hamster is the same thing as hamster divided by 1. Even though this is stupid. I know this is stupid. But so here's your y. Here's your x. So this must be hamster. This must be x. This is 1 squared plus hamster squared. I'm out of time, so I'll just do that. So the sine of this would be hamster divided by 1 plus hamster squared, square root. Very, very silly example. However, you really need to see that these, in many ways, are just simple forms, and they don't necessarily even have to have meaning like you're used to seeing. We'll be back in a second.